Welcome to this video. So here in this question they have given this E naught values for titanium 2 plus 2 titanium, that is reduction potential, V2 plus 2 vanadium, Mn3 plus manganese 2 Mn2 plus, V3 plus 2 V2 plus, cobalt 3 plus 2 cobalt 2 plus. All these are reduction potential, we call it as. Reduction means what? From higher oxidation state it has to come to lower oxidation state. That is metal in 2 plus, it will come to lower oxidation state, or from higher oxidation state, that is Mn3 plus, it might come to Mn2 plus. So all these we call it as reduction potential, right? Because reduction happens. So they have given, so for titanium it is minus, for vanadium it is minus, for manganese Mn3 plus to Mn2 plus it is plus. It means easily it will undergo this reduction, easily reduction, very easily it will undergo reduction. Easily reduction means it act as what? Act as good oxidizing, it act as good oxidizing agent, act as good oxidizing agent, right? So here for example, next V3 plus to V2 plus it is minus, and last that is what? Cobalt 3 plus to cobalt 2 plus plus 1.97 volt. So identify the incorrect statement. It means A, B, C, D. Within this, three will be correct statement. Only one will be what? Incorrect statement. That we have to identify. Right. So here I told this manganese 3 plus to manganese 2 plus, it is plus 1.57. Since it is positive, it means that greater, we know that greater the reduction potential, easily it will undergo reduction, easily it will undergo reduction, easily it will undergo what? Reduction. Easily it undergo reduction means it act as what? Act as good oxidizing agent, good oxidizing agent. So manganese 3 plus to manganese 2 plus, so here they have called manganese 3 plus and cobalt 3 plus. Similarly you can see that cobalt 3 plus to cobalt 2 plus, it has got positive. Positive means the same formula you have to apply. Positive means greater is there, what? Reduction potential, sorry, greater reduction potential. So easily it will undergo reduction, act as what? Good oxidizing agent. So both act as strong oxidizing agents. So this is the correct statement, but they have asked us the incorrect statement. So option B is our not the incorrect statement, because it is correct statement. So this is not our answer. So let us talk about this option C now. See, in option C, Mn2 plus is very stable due to stable d5 configuration. Let us see, manganese atomic number is 25, so it is, sorry, Mn, it is argon 3d5 4s2. So here manganese, I should write it and 2 plus oxidation state. It means argon, I have to remove 2 electron from 4s, I will get what? 3d5. So 3d orbitals, we know that it has got 5 orbitals, dxy, dyz, dzx, d square minus y square, and dz square. So 5 electrons, if I put 1 electron, 2, 3, 4, 5. So this is d5 configuration. Since 5 electrons are half filled electronic configuration is stable, we know that. So this is the stable configuration. So manganese Mn2 plus is very stable due to stable d5 configuration. So this is also correct statement, but they have asked incorrect statement. So this is not our option B and C. Let us talk about A. So A, titanium 2 plus and vanadium 2 plus are strong reducing agent. So here if you see the reduction potential value, titanium is negative, means it doesn't undergo reduction. Vanadium 2 plus to vanadium, it is negative. I have told greater means what? Positive reduction potential, easily reduce, easily they undergo what? Reduction. Since they are undergoing easily reduction, they act as what? Good oxidizing agent, right? So since they are having negative, see, for titanium 2 plus to titanium it is negative minus, and from vanadium 2 plus to vanadium it is negative minus 1.18 volt. So they are having negative, say, so they are not good oxidizing agent. Then what it will be? So since they are having low, that is negative reduction potential, so they won't easily undergo reduction, easily undergo what? Oxidation. So act as what? Good reducing agent. So option A, if we read, the strong reducing agent and liberate hydrogen gas with dilute HCl, because all metals when reacted with HCl, they forms metal chloride. Along with that, there will be liberation of hydrogen gas, right? So this statement is also correct statement, but they have asked incorrect statement, right? So this is also not our option. So my option is this one, D. What? V2 plus is less stable than V3 plus. So this is incorrect statement. Incorrect statement. So this is my option. Then you will ask, sir, yes, okay, we read about A, B, C, all are correct statement. So this is incorrect statement. But you will ask me, sir, explain why V2 plus is less stable than this V3 plus. Let me talk about this. So here V2 plus is there, right? So let us write the configuration of vanadium, scandium, titanium, vanadium. So 23, argon 3d3, 4s2. So scandium 2 plus, sorry, vanadium 2 plus, argon 3d3. 2 plus means I have to remove 2 electron from 4s, it becomes 4s0. Vanadium 3 plus means what? Argon, again I have to remove 1 electron, 3d2. So here 3d3 is stable configuration, stable electronic configuration. 3d2 is unstable electronic configuration. This is unstable electronic configuration. You will ask, why sir 3d3 is stable electronic configuration? If it does any octahedral splitting, it will be having octahedral means what? Down T2G will come, down T2G, above what? Easy. So 3 electrons can half filled like this. So here T2G is, if we split, 3 electrons are half filled. Because of that half filled, it has got stability. So V2 plus is more stable compared to V3 plus because it has got 3d2 electron configuration. But here they have written that V2 plus is less stable than V3 plus. No, V2 plus is more stable than V3 plus. So what happens? So that is the incorrect statement they have given it, right? So since the question asked is incorrect statement, all A, B, C are correct statement, D is the incorrect. So this is the option answer for your question. Thank you.